What's up, guys? Today we're going to be going over area, models, and probability. So we're going to go over the sections of the shaded to represent probability, so the shaded part. There is 1, 2, 3, 4 in all. How many are shaded? 2. Can you reduce 2/4? Yes, to 1/2. Over here there's 1, 2, 3, 4. There's 4 sides again. Only 1 is shaded. You can't reduce 1/4, so you're done. Over here there's 1, 2, 3, 4, 5, 6, 7, 8. And only 3 are shaded, so 3 out of the 8 are shaded. You cannot reduce 3 and 8, so you're done. 2, 3, 4, 5, 6. 4 out of the 6 are shaded. Can you reduce 4/6? Yes, to 2/3. This page wants you to draw them and make one yourself. So you're going to do this on your own. A hexagon has 6. You know what a rectangle is. You know what a circle is. And an octagon has 8. If you can't draw them perfect, don't worry about it. For example, number 4. Use a circle split into equal sections to represent 25%. 25% is 1/4. So we have a circle cut into 4 pieces, and only this one's colored in. Should look something like that. So that's what you're going to be doing on 2, 3, and 5. Try that on your own. Number 6, good question. It says, after Gerald finishes his homework, he must play a game of chance to determine how he will spend the rest of his evening, using the spinner below. Determine the probability and percent of his spending the evening doing each event. So, sector A is playing with your sibling. That belongs with this one. B says he's going to go to the mall. That is B. C says he's going to clean the garage and the workroom. And D says he is going to play in the garage, or play in a friend's garage, sorry, which would be D, which is 30%. Now, it's real easy here to find all the degrees, sorry. Let me show you. If you take a look here, this is a line going through the center all the way through. They call it the diameter. The diameter is 180 degrees. Is the line from here to here, 180. You already have 60, so to find C, 180 minus 60 gives you 120. Same for the top, from here to here, 180. So to find A, 180 minus 30 gives you 150. So that's 150 degrees. Let me make it nicer. So now we have all the degrees. Now we can easily figure out the percent and probability, A. So we're only going to look at the A, which we know is 150. It's 150 degrees of the full 360. Right? Because the full circle is 360. So 150 over 360. And then it's easier if you already put times 100. And that gives you the percent. 41.6%. So that is percent. Now the probability would be just the numbers, 150 over 360, and reduce this. We can reduce it to division by 3, and it gives you 5 over 12. So this is probability. So 41.6%, 5 over 12 is the probability. And you would do the exact same thing for B, C, and D. Now for B, going to the mall would be B, which is 60%. 60 degrees, sorry, geez. 60 degrees over 360 degrees times 100, so you can get the percent. And that gives you 16.6%. So Gerald has a 16.6% chance of going to the mall. What is the probability? 60 over 360 and reduce, which is really 6 over 36, which is really 1 over 6. So he has a 1 and 6 probability of going to the shopping mall. And that's exactly how you do C and D. So you all do C and D and try it. And we'll go over tomorrow in class. Number 7. What is the probability that a random dropped counter, or like if you drop, like, I don't know, they use counter because it means it's not going to bounce. Like, it will just fall straight to the ground and stay there. So what's the probability that it would fall inside the trapezoid if you just dropped it? Well, first, the trapezoid is inside this gridded area. That's the hole. So we'll just have to figure out the area to the hole. So let's see. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 10 by 10 little graph type deal. It's a square, so 10. So length times width, 10 times 10, which makes 100, of course. So the area of the hole, I'll say the area of the rectangle is 10 times 10, which is 100. Now the area to the trapezoid is found by doing 1/2 B1 plus B2, which are the bases, times the height. Lucky for us, the bases are easy to count right here. They're straight up and down. So it is from here to here, which is 3. So it's 1/2 times 3 plus from right here to right there. You count it and it should give you 7. This is 3, and this is 7. Now the height. The height is also pretty easy to count. It goes from right here all the way up to here. This right here. This is the height. If you count that, it gives you 6. So that is my height, 6. You put that in the calculator. 7 plus 3 is 10. Half of that is 5. 5 times 6 is 30. So the area to the rectangle is 100, and the area of the trapezoid is 30. And it wants to know, what is the area that it will fall inside the trapezoid? Well, the trapezoid is 30. All of it is 100. So we make a little fraction. The probability that it will fall inside is 30 out of the whole 100. That's a probability. 30 out of 100. And if you can reduce, you always reduce. Which gives us 3 over 10. So you have a 3 out of 10 chance of dropping the counter on the ground and it falling inside the trapezoid. Now, 3 out of 10 is the probability. Just because I want to ask you, what's the percent that will fall inside? 3 out of 10 is the same as 30%. Just FYI. Should know that. Now number 8. this bad boy right here. This is a good question, number 8. You can try it, look at it, and don't try to solve it, just look at it and think about how we would do this. We're going to go over that one tomorrow in class, number 8. Number 9. In the U.S., approximately 2 out of 5 people wear a seatbelt while driving. That's very bad. Anyways, if 2 people are chosen at random, what are the following probabilities? It says, what happens that if they both wear seatbelts? Well, if they both wear seatbelts, then that's 2 out of 5 people. And another person is also that 2 out of 5. Now, with probability, you always multiply. Kids always get messed up that you always multiply. 2/5 times 2/5. You can simply put it in the calculator, which is no problem. Or you can just know how to multiply straight across, which would give you 4/25. Four out of 25 people, 4 out of 25 chance that they both wear seatbelts. Which, if you put in the calculator, gives you 16%. If you don't know how I get this 16%, ask me tomorrow, please. So that'd be for A. Now for B. What happens if only one of them wears a seatbelt? So again, you're choosing 2 people because it says you're choosing 2 people. If only one wore it, well then that would be 2 out of 5 times the next person. And you think about it. If 2 out of the 5 wear the seatbelt, then how many don't? If 2 out of the 5 do, that means that 3 out of the 5 do not. Alright? If you don't get that, ask me tomorrow. So we just multiply here, and it gives you 6 out of 25. So 6 out of 25, which is 24%. And then the last one, C. If neither of them wear seatbelt, so we have 2 people, and neither one were going to wear a seatbelt, that would be 3 out of 5 times 3/5. Put that in the calculator or just multiply it if you know how. It gives you 9/25, which is 36%. And then you can try number 10. If you can do it, that's awesome. If not, well, I'm just going to show you a little bit how to do it, but it's your responsibility to know how to do it. Oh, and one last thing. When you all drive, make sure you put on your darn seatbelt. That is way too low for people not wearing seatbelt while driving. Jeez. Nothing to do with math, I know, but just because I care about you all.